Kia ora koutou. Thank you for joining us today in this session of the Thriving Cities webinar series. My name is Rachel Napier and I'm the Program Manager for People, Cities and Nature, and I'll be your host for today. This webinar series explores what it means for cities in Aotearoa New Zealand to create truly thriving biodiversity. And today's session is about a really crucial part of biodiversity management for New Zealand cities, and that is predator control. So first, we're going to hear from Stephen Hartley, who is an ecologist at Victoria University of Wellington, whose research supports the design of biodiverse connected urban landscapes. After Stephen, we'll hear from Tamara Encina-Becker. Tamara is a veterinarian and a PhD student at Victoria University of Wellington, whose research focuses on interactions between introduced mammals and urban predator control, with an emphasis on mouse population dynamics, individual behaviour, and toxoplasmosis. After Tamara, we'll have time for questions, so please use the Q&A function at any time to ask your questions, and we'll get to as many as we can at the end. So first up, Stephen.
Kia ora tātou, ko Stephen Hartley aho. I'm from Te Herenga Waka, Victoria University of Wellington, and thank you, Rachel, for the introduction. So the brief outline is to cover some of the monitoring methods used for figuring out what urban predators are present, how they're adapted for urban situations, some national comparisons where we've done this monitoring, and then looking at Predator Free Wellington as a case study, and in particular focusing on the effects it's had on rats, mice and hedgehogs, the small mammals, and some biodiversity responses from wētā, fantails and lizards. And then after that, I'll hand over to Tamara, who will focus in on mouse densities under 3 different predator control regimes in Wellington. So the methods we've developed are basically adapted from the backcountry standard, true and tested methods of tracking tunnels, chew cards and trail cameras, but we just had to be a little bit more flexible in how they're spaced out. So we still aim for 50-meter spacing on a kind of a line, but the line can be a bit wiggly, or it could be a grid, or even just a cluster of sites that were roughly 50 meters apart from each other. We use erased rabbit paste because we've been trying to pick up mustelids as well as rats, and we found that a 6-day exposure, you get just as many rats with peanut butter as you do with arrays. So comparing the methods of chew cards and tracking tunnels, they do have different biases and sensitivities. So we found that chew cards were relatively more sensitive for picking up rats and possums, whereas tracking tunnel cards were more likely to detect mice and especially hedgehogs. Not surprisingly, we detected virtually no cats with either method. But also, if you look at the consistency of interpretation, which is particularly important, perhaps using volunteers or people who are not highly experienced in looking at these, there was a much greater consistency between observers with the tracking tunnels for rats, mice and hedgehogs, but not for possums. Possum detections were much more consistent with chew cards. So chew cards are our preferred monitoring tool for possums, our preferred cheap monitoring tool, and tracking tunnels for the other small mammals. But so the advantages of tracking tunnels and chew cards, they're well-known technologies, they're quite cheap and can be reliably interpreted for the correct species, but neither technique detects all species. So it's difficult to pick up possums and mustelids in tunnels. Chew cards also have the downside of leaving some plastic shreds if they're eaten by rats. And cameras, although they detect all species and they create a lot of data, they're quite an expensive outlay. And jumping forwards, and there's some issues with data management and public privacy about where you can place them in an urban situation. When we looked across 5 different cities, we found that sort of hedgehogs, mice and rats were the most often detected species using tracking tunnels and chew cards. As I mentioned, mustelids and cats very rarely detected. Dunedin had the highest detection rate of possums and of hedgehogs. Possums, hedgehogs at the top. Wellington, virtually no possums detected, and that we put down to sort of 20 years of pretty effective possum control across Wellington. There's also the hint that there might be some latitudinal trends with the sort of the larger mammals, hedgehogs and possums, becoming more abundant as we go south, and the rodents, rats and mice becoming more abundant as we head north towards Tauranga. If we do use cameras, and this is a camera survey done in Wellington, we pick up a whole range of mammals. And top of the list was cats, followed by hedgehogs, rats, possums, mice, and rabbits, and only one dog. So the bias of cameras is towards larger mammals, so they're more easily able to detect cats and dogs and possums, but they're generally as sensitive or more sensitive than tracking tunnels for all species except for mice, and just mice are a little bit smaller. They don't always trigger the cameras as regularly. So now focusing in on Te Whanganui Atara, the Wellington geography. Essentially, the large peninsula is half urban and half rural hinterland. And the results I showed you just previously were kind of a mixture of both that urban and hinterland environments for the camera survey. But I'm going to focus in on Predator Free Wellington, which is one of the landscape scale projects supported by Predator Free New Zealand 2050 and the Next Foundation. It was launched in 2018 with the goal of eradicating rats, mustelids and possums from all of Wellington, done in 5 phases, starting with phase 1 Miramar Peninsula, and then gradually moving out and swinging round up towards Makara and Pororua. So the phase 2 rollout is now underway, the Island Bay to CBD area, but most of the results I'm going to show you are a before and after comparison of what happened when phase 1 at Miramar. So Miramar is our kind of experimental high intensity eradication attempt, and the rest of Wellington is our sort of control from an experimental point of view. And the survey design had 24 transects, each with 10 tunnels, and they were spread across 8 suburbs, and within each suburb there was a mixture of amenity locations, which is like sports fields or coastal habitats, urban forest reserves and residential gardens. And the results I'm going to summarize into 3 groups: the Miramar Peninsula, which had the eradication attempt, phase 1 Predator Free Wellington, the central suburbs and the western suburbs. And phase 2, which has just started, is kind of halfway through the central suburbs. So just bear that in mind. And an additional monitoring device we had out were wētā motels, so 4 of these per transect. And these are artificial retreats for invertebrates, but particularly good, well colonized by Wellington tree wētā. And with those, we're able to actually count individuals. So cutting straight to the chase of what happened to the rats with the Predator Free Miramar, which sort of started back in 2016 and 17, but the actual Predator Free Wellington high intensity eradication attempt began in July 2019. The 3 suburbs were kind of similar, and then straight away rats went down to undetectable levels, or at least within a few months, but by the time we did our next survey. And then we never detected rats at all, apart from a single footprint on a tracking tunnel in May 2023. And so with 60 tunnels, we're not detecting rats. Predator Free Wellington have additional monitoring out there, and they rely on public sightings. And so we know there are a few rats have been popping up and down over that time, but at such a low level that from an ecological point of view, they're essentially eradicated. Mice, they also were brought down to undetectable levels with the initial rollout, but they were never the target, and so they were still present at lower levels in Miramar compared to the other suburbs, and they've stayed quite low all the way through to sort of by about May 23, when the targeting of rats kind of was eased off because rats had been declared eliminated. And over the last year or 2, we've seen mouse numbers in Miramar Peninsula climb quite considerably above what they are in the other suburbs. Hedgehogs, meanwhile, have stayed pretty much the same in all 3 suburbs over that period. But from a reason we're doing this is to try and have an impact on native biodiversity. And so tree wētā when the motels were first put out, they were empty, and then they gradually got colonized over a 2-year period. And then the eradication attempt began in Miramar Peninsula, and within 6 to 12 months, we saw a real jump in the occupancy of tree wētā in these wētā motels, and now consistently twice as many in Miramar Peninsula as the other two suburban areas. So a great gain for native biodiversity. And then I'll quickly just tell you about two other surveys. One was looking at fantail waka waka nesting. And the background to this is that the numbers have seemed to have been climbing over the number of years, and possibly even began climbing with the community trapping efforts back in 2016, 17 and 18. And the actual nesting success rate that Samantha recorded in 2023-24 was around 90% fledged nests. No predation events observed, just a couple of abandoned and deserted nests. And this success rate is extremely high, around 90%, much higher than what was recorded back in 2015 and 16. And that was a similar rate to what was recorded in Dunedin in 2007 and 8. But we see there's a lot of variability because in Dunedin 2006 and 7, the success rate was very low. So other factors such as weather also have a big impact on fledgling rates. The final result I want to highlight to you is some lizard surveys, again done in Miramar Peninsula and the rest of Wellington. And with copper skinks, they've stayed pretty consistent at fairly low levels across the rest of Wellington, whereas on Miramar Peninsula, some sites they were low and have stayed low, but a couple of the sites there's been some definite increases over a period of years. And that same result has been shown with another species, the northern grass skink. It suddenly kind of had a bit of a blip in Wellington in 2022. But if we look at the other sites, again, a couple of sites had increases, one has modest increase since the eradication or elimination of rats in Miramar. So that's all I want to speak about now. I'll hand over to Tamara to carry on the story.
Now that the predators are gone, mice are more active, and that's what I see in the field and what my data shows. So I'm specifically studying mouse population dynamics in a changing predator urban landscape. And my research focus are quantifying whether targeted and intense predator control leads to compensatory population increase in mice. So for Aotearoa context, here I'm showing a simplified food web highlighting trophic interactions driving mouse population changes after predator control. So with rats and mussels eliminated, their predation pressure is gone, which is shown by this faded arrows. But although that cats remain as apex predators, the reduced overall predation and competition allows mice to increase, effect known as a mesopredator or competitor release. So as mouse rise, they exert more pressure on native species like lizards and invertebrates, shown by this downwards negative arrow. And the second research focus is exploring the spatial and temporal movement dynamics, analyzing how predator control affect mouse movements and trappability. So to start off with my methods, I'm using live trapping and spatially explicit capture-recapture to model mouse densities, spatial scale of detection, and detection probability. Seeker models estimate these three parameters simultaneously through their spatial relationship. So we start with detectors laid out in space, here represented by the white crosses, and then we observe where the animals are detected, which are represented by the triangles. So each detection gives us clues about where the animal's home base is and the activity center is. And in this graph, this curve shows the detection probability, which is highest near the activity center and drops off with distance based on the animal's behavior. This is described by sigma and is often following a bell shape or a half normal curve. So by combining all this information and the detection histories, we estimate the densities of animals in the area. And so Seeker help us to go beyond simple counts and give us a spatial explicit realistic estimate of population size. But the space is not only the only part of the story. To understand changes over time, we also look at the temporal scale, specifically how these patterns change across season. So our study spans 7 seasons. 4 are already completed, and each season we conduct 6 nights of capture, mark recapture, and run continuous 30 days camera trapping at each site. And another key factor is what's happening in the environment. So we explore 3 predator community scenarios driven by different levels of introduced mammalian predator control. And each scenario represents a unique combination of predator species present at a site. So my first scenario is Miramar. And in here, there's intense targeted predator control. And in here, I have 48 mouse live traps spaced out by 10 meters. I have 8 camera traps randomly placed within the mice grid, targeting mice and cats, and 9 camera traps are at a broad-defined scale for cats, and which are represented by the purple stars. The second scenario is Karori, which has community-led and sparse council predator management. And in here, I have 50 live traps spaced by 10 meters and 10 camera traps randomly placed within the mice grid, targeting mice, rats, and cats, and 9 camera traps at a broader fine scale for cats and rats. And then the third scenario is Zealandia, which do management through annual poison baiting and snap trapping. And in here, I have 65 live traps by 10 meters and 18 camera traps randomly placed in the mice grid, targeting mice. So some of the results to date. So mouse populations increase significantly at the site with intensive targeted predator control, providing a clear evidence of mesopredator release. And on average, densities in the rat-free Miramar are 56 individuals per hectare, nearly 8 times greater than rat-present Karori, which has 8 individuals per hectare. For the scale of movement, I modeled this as a function of sex and season. And in Miramar and Karori, movement scale varies by both station, which are the seasons, and sex. Males and females differ in how far they move, and the way they move change over time. So in Miramar, males generally have a higher or equal sigma, which is the movement scale. And in summer and winter, the sigma is lower than females. But in general, the population has a constrained scale of movement across the seasons. And in Karori, males in spring and summer move more than females, but this pattern reverses in autumn. For Zealandia, we could not model because of the low sample size, so we cannot say a pattern at present. So what are the implications for practice? So building on ecological gains Stephen presented earlier, eliminating possums, mustelids, and rats entirely is a tough goal, but it's within the reach in urban settings. However, the ecological responses to pest control unfold over time, and 3 wētā populations rebounded quickly and stayed high for 4 years, while Lisa responded more slowly, and Waka Waka appears to track along with these changes. However, the effects of recent mouse increase remain unclear. And so, of course, while the ecological gains are encouraging, they come with important caveats. Pest control effort can also produce unintended consequences that may offset some of the benefits of the conservation benefits, particularly for ground-dwelling species such as lizards and invertebrates. And there are also public health implications. An increase in mouse population may elevate the risk of zoonotic zoonotic disease transmissions like Toxoplasma gondii, high mouse densities with constrained movement like in Miramar can create localized disease hotspots, or pathogens loads in areas near human habitation. And also more mouse population also pose risk to urban infrastructure, can damage electrical system, building insulation and stored goods. So taken together, this risk highlight a crucial point, which urban planning can't afford to treat predator control in isolation. Instead, it must take a whole ecosystem dynamic into account. So here's the acknowledgement for all the people involved in this project. And that was the end of the presentation. Kia ora, thank you, and we're open for questions.
The first question is for Stephen. The question is, with Western Wellington being the control in your experiment, but having greater pest control than other cities in the country, was there any thought given to using Porirua or Waikanae as the control?
Thank you for that question. Yes, we would love to probably be comparing to a wider range of cities, but in order to try and keep things consistent, we constrained it. So we're comparing Wellington with Wellington, but acknowledging that Wellington does have a relatively high level of pest control in terms of what the council does for possums and in terms of community engagement with rodents. So yeah, I mean, that's why we did have the other surveys in Tauranga and Hamilton and Dunedin and New Plymouth as early comparisons.
Thanks, Stephen. Our next question, with the lizard study, are rainbow skinks present, and do you expect that they have an impact on native lizard species?
I can take that. I'm not aware that they're present in Wellington itself, but I believe just given the high numbers they can get to, I'm pretty sure they would have impacts on other lizard species. I'm not a lizard expert. I should have said I was presenting that work on behalf of colleagues.
I also had a question on whether you could talk to, I think a lot of the people on this webinar represent regional councils and predator free initiatives. So what would you say are some of the challenges of pest or predator control in urban areas versus forest reserves?
Yeah, I think the big challenge is just that urban areas are divided up in terms of property ownership on a very fine scale. And so there's only some areas that you can easily access. I mean, we had to get permission from lots of residents to access their gardens for the monitoring. And the same was true for Predator Free Wellington when they wanted to put out bait stations. I mean, Predator Free Wellington is using a pest control density of 4 bait stations per hectare, which is much higher than most sort of standard practice urban predator control. But I would say even lower levels, say 1 bait station per hectare, can probably be effective and provide benefits for some native biodiversity, such as the slightly more resistant species like the P. waka waka. But for the more sensitive species like lizards, you really do need high pest control in areas where you can sort of maintain it consistently and keep out invaders, because it's always going to be a bit fragmented. So there's often going to be invasions from the edges, and it's a much more fine scale landscape than a backcountry forest.
Thanks, Stephen. And the next couple of questions is for Tamara, because it relates to mice. So you highlighted in your talk how when we're controlling other predators, that mice can become an issue. So is there a way that we can control mice in urban areas, and what's the best way to do that?
Well, yeah, we always can do poison baiting. And I guess it is like a easy and like a broader way that you can target landscapes, but in terms of urban and also perhaps you can include the community and help them to teach them how to bait mice and but yeah, so I guess the baiting is a good one. And in terms of, from my data, it seems that when they are high populations, the toppability is quite good. So they tend to come to traps or baits. So that's, I guess, trapping with bait or snap trapping as well.
Thanks, Tamara. Any other comments on controlling the mouse problem, Stephen?
I think, what Tamara summed it up. The two main options are bait stations, which are probably more effective, but trapping around houses can also help protect that infrastructure and avoid mice coming into houses. I mean, just to go back to one of the earlier questions, I would also point out that with predator control, I think possum control in urban areas is well within reach of all cities and councils. I mean, they're lower densities, they're more habitat preferences for the forested areas, and so you can really have good targeted control against possums.
Do you think there would be any flow-on impacts if we're controlling mice to native birds like ruru who feed on them?
I think if you could get rid of the full suite of predators, rats and mustelids and possums and mice, then the native insects would thrive so well that ruru would have plenty of wētā and other things to eat. So I don't anticipate a negative consequence for ruru from eliminating mice.
I agree. That sounds like a wonderful image to have everything thriving so well. So that is about all the time we have for questions today. And kia ora, Stephen and Tamara, for sharing your results and your research with us today. And thank you also to everyone that joined. It's been wonderful to have you with us. We'll follow up soon with links to the presenters' research and any other resources they'd like to share. You'll also be able to watch this session again on YouTube, our YouTube channel, if you would like to. And our next webinar will be in September, focusing on a case study for Māori-led restoration in Taranaki with Sarah Gibson from Taranaki Maunga and Professor Bruce Clarkson, who also hails from Taranaki.